Hello everyone, Carson here, and in this video, I'm going to be solving Wordle number 1196 and New York Times Hard Sudoku for September 27th, 2024. So let's get this video started with Wordle number 1196. I'm going to start with the word raise. Okay, got the A and I green, which is what I know. Wait, what did I just say? Which was not what I was expecting to get as the clues. So I actually got a double vowel AI, and I mean in the second and third position. Um, see, it literally can be anything. It could be paint, it could be faith, right? See, I think it's most likely for the last two letters to be a double consonant, but it's also possible for a Y to, pop up. Um, but it's not that likely. Daily is one example. So let me actually ignore the clues. Let me ignore A and I, and I'm just gonna guess a totally different word. Um, okay, so what were the options I thought of? Paint. So I want to use the N and T. For faith, I want to use the H. And for daily, is it possible to use the L and Y? So we got N and T from paints. We got T, which is repeated, and H for faith, and L and Y from daily. I might exclude the H. Hmm. Can I form a word with N, T, L, and Y? Like, is ton... This is not a word, definitely. No, okay. Um, hmm. How should I do this? I'm gonna have to use a T, definitely. Let's try... Okay, let's try blunt. Okay, there is a T, which is making me think it's faith. And I'm actually gonna try to guess that. The answer is indeed faith. Alright, so I did actually think of that after I guessed. I mean, after I made the first attempt. One of the three words that I thought of. So yeah, um, I kind of already predicted the answer, but I just didn't know which one it was most likely to be. But yeah, after the process of elimination on the second try, um, I immediately tried guessing faith, and it indeed was the correct answer because of you know, all the predictions I made and the reasoning behind. So yeah, got today's Wordle answer faith in 3 tries. So yeah, I'll definitely take that. So yeah, this is Wordle number 1196. After I'm done with this, let me move on to New York Times Sudoku. So I'll be solving the hard difficulty Sudoku for September 27th. So let's get started. This 9 points down, so in block 7, the digit 9 is forced into column 1, and then these 9s point up. These 9s point right. I think that's all I'm gonna mark for 9s. These 1s force the digit 1 into this cell in block 4. I can force the digit 1 into one of these two cells in block 8. These 1s point up and this cell sees another 1. This 6 points down, and the 6 points left. So in block 4, the digit 6 is forced into row 5. Okay, these 7s force the digit 7 into one of these two cells in block 8. So now we have a 1-7 pair in block 8. As you can see in block 8, the digits 1 and 7 are missing, and these 1s and 7s force both 1 and 7 into one of these two cells only, but they share the same two cells. So the only combinations are 1-7 or 7-1. No other combinations. In order to fit both 1 and 7 into block 8, they have to go into these two cells, or in other words, these two cells have to be reserved for 1 and 7, as they are the only two digits that can go into these two cells. So all other digits are eliminated from this 1-7 pair. Note that, I mean, I can't really mark any digits down, because, I mean, any restricted placement of digits because of this 1-7 pair, but if there are any later, of course, I'll show it. Alright. This 8 points down and this 8 points left. So in block 5, the digit 8 is forced into row 5, and then these 8 points left. Okay, same with the 5s actually. This 5 points up and this 5 points right. So in block 5, the digit 5 is forced into one of these two cells, and a 5-8 pair is formed. As you can see, in block 5, the digits 5 and 8 are missing, and these 5s and 8s force both 5 and 8 into one of these two cells only, and they share the same two cells. In order to fit both 5 and 8 into block 5, they have to go into these two cells. The only combinations are 5-8 or 8-5. So these two cells have to be reserved for 5 and 8, therefore eliminating all other digits from this 5-8 pair. It's basically the same logic as this 1-7 pair. Same logic. Again, don't really see any digits affected immediately by this 5-8 pair, but once again, I'll let you know if I see any, just anything affected. Oh, but now we know that 5s are here. This 5 with 5s in, like, okay, no matter which cell the 5 ends up being in, it's guaranteed to be in row 5. So this 5 and 5's here point right. So force the digit 5 into this cell in block 6. Or you could have just looked at row 6 and said that I have to put 5 somewhere in row 6 as it's still missing. But these open cells see another 5, which leaves just this open cell available for 5. So 5 has to go here. Alright, these 5s point right. Okay, I was just looking at row 3 and I was seeing what digits they were missing, and I found that the cell is a single 3. Okay, so I can place all the digits in and eliminate the digits that the cell sees one by one. So what I mean by sees is that it, you know, think about every cell that, imagine every cell has eyes. Imagine. So they have eyes, right? So they see the digits that are in the same row and column as that cell. And, okay, row, column, and block. Row, column, and block. So this cell sees 1, 2, 4, 5, 6, 7, 8, and 9. So I've eliminated the digits that the cell sees. Okay. Another way to explain the term C is that how do I put it? Well, I don't really give a definition of a Sudoku term. So, well, if you see a digit, that means that digit is in the same row, column, or block as the digit that goes into the cell. Right. I'm sure you get what I mean. It's just I don't know why I even need to explain that. Okay. So this cell cannot contain 1, 2, 4, 5, 6, 7, 8, and 9. But we still had to fit one digit into this cell, but cannot be these 8. Cannot be these 8 digits apart from 3. 3 is the only 3 is the only digit that can go into this cell. So I have to put a 3 here. It can't be anything else, and in Sudoku we cannot have empty cells. We don't want empty cells, so we have to put a digit into this cell. It has to be a 3, because it can't be anything else. Okay, and then in block 6, 2, 3, 7, and 9. In block 6, 2, 3, 7, and 9 are missing digits. These two cells C, 3, and 7. So the other two open cells in block 6 form a 3-7 pair. It's the same logic as the 1-7 pair in block 8 and the 5-8 pair in block 5. So I'm not going to explain it again because it's a bit time consuming. So remember that this 3-7 pair eliminates all other digits from these two cells, meaning that 9 can no longer go into this cell. I can force the digit 9 into this cell in block 6, which also makes this a 2... okay. And then this 2... Sorry, I just forget to turn off the notifications when I'm recording. Excuse me. Alright, now that I place this 2, I can say that this 2 points left, and 2 cannot go into the 5-8 pair. So in block 5, the digit 2 is forced into column 4, and then these 2's point down. This cell sees another 2. Okay, these 9's point down, and I noticed that these 9's line up. Okay, so actually found out that this pattern is called a mini X-wing. So what it does is that no matter if 9 goes in this pattern or in the other way, all of these open cells in block 8, which are in rows 7 and 8, see the 9s. These 4 open cells see 9 because they're either placed like this or like this, which will see both of the 9s. So none of these open cells can contain 9. So in block 8, the digit 9 is forced into one of these 3 cells. Well, into one of these 2 cells, because this cell also sees another 9. So by explaining, okay, if you see this pattern concerning the placement of 9s, then this mini X-wing will eliminate 9s from these open cells. Therefore, the 9 ends up being down here. Or another way to see this situation is that just look at row 9. In row 9, 9 is still a missing digit. So I have to place 9 somewhere in this row. This cell sees 9, this cell sees 9, and these 2 cells also see another 9. So where does 9 go in row 9? It has to go into one of these 2 cells, because no other open cells in this row can contain 9. So 9 ends up in one of these 2 cells for this row, and because 9 is guaranteed to go into one of these 2 cells, all other open cells in block 8 cannot contain another 9 because they're already here. So yeah, two ways to see this situation, two ways to explain it. They have the same outcome, so it really depends on which one you use, which one you see first, and which one you prefer. It doesn't matter because same result. So just use the one which comes to your mind first, and no worries. Okay. Really taking a lot of time explaining the things, so I'm gonna try to speed this up. In row 6, 2, 7, and 8 are the missing digits. This cell sees 8, so it's 2, 7. This cell sees 2, so it's 7, 8. This cell sees 7, so it's 2, 8. Hmm. In row 3, the missing digits are 4, 5, and 7. This cell sees 4, so it's 5 or 7, and this cell also sees another 4. But 4 is still a missing digit of row 3, but cannot go into these two open cells. So in this row, the digit 4 is forced into this cell, and this 4 points down, and this 4 also points left. So in block 7, the digit 4 is forced into this cell, which makes this cell a 9, because this 9 points down, and now that 4 occupy this cell, 9 must end up in this cell. Okay, 9 in this cell is now eliminated. I can force the digit 9 into this cell in block 9, which makes this cell a 5, because these 5s points right, and 9 occupy this cell, which removed one of the two possibilities for 5. So 5 has to go here. In row 7, 2, 6, and 8 are missing digits. This cell sees 2, so it's 6 or 8. This cell also sees a hidden 2, so it's 6 or 8 only. So, okay, if you're still confused, this 2 points left, and 2 cannot be in the 5-8 pair. So in block 5, the digit 2 is forced into one of these two cells that are both in column 4. So if 2 is guaranteed to go into one of these two cells, 2 in this cell is eliminated. We cannot have a 2 into this cell because 2 being in this cell will clash with this 2. So I have to eliminate 2 from this cell, and this cell also sees 2. So in row 7, the digit 2 is forced into this cell. Okay, these 2's points right, and this cell sees another 2. So in block 9, the digit 2 is forced into this cell, and the missing digits of block 9 are 3, 6, and 8. The cell sees 6, so it's 3 8. The cell sees 8, so it's 3 6. The cell sees 3, so it's 6 or 8 only. Might as well fill in column 8. The missing digits are 1, 6, and 8. The missing digits of block 7 are also 3, 6, and 8. Well, for the 6, 8 part, yes, also, but you get what I mean. 3, 6, 8 triple. Okay, so this cell actually cannot contain a 6 because it sees the 6 from block 7. So if I put a 6 here, it'll clash with 6's down here. So this cell cannot contain 6. I can force the digit 6 into this cell in block 4. Because of this 6 as well, right? So 6 goes here. Um, okay, so I see that. This cell sees 1, does not see 2, sees the 3 down here, sees 4, sees 5, sees 6, does not see 7, sees the 8 down here, and also sees 9. So only 2 and 7 can go into this cell, and look at block 4 again. these 3 cells only contain the digits 2, 7, and 8. And because we do not want any empty cells, because we cannot have empty cells in Sudoku, we have to keep 2, 7, and 8 into these 3 open cells. We have to keep these 3 digits into these 3 cells because it's to avoid empty cells. Nothing else can go into these 3 cells apart from 2, 7, and 8. So I have to keep these 3 digits into these 3 cells. So because of this 2, 7, 8 triple, 2s, 7s, and 8s are eliminated from these 2 cells. Or I can do it the other way, which is to directly make this a 3-4 pair because of these 3s and 4s. Yeah. So in column 1, 3s are up here, right? Or you can say in block 1, 3s are here. And 3s, these 3s force, well, I'll just say 3 and 4 at once, okay? All of these 3s and 4s force both 3 and 4 into one of these 2 cells only, and they form a 3-4 pair. Same logic as the 1-7 pair and this 5-8 pair. So I'm not going to explain it again, but it's just that this 3-4 pair eliminates all other digits from these 2 cells, making the other 3 open cells containing 2, 7, and 8. Okay, and then these 3 cells form a 7, 8, 9 triple. Okay, and these 3 cells form a 2, 5, 7 triple. Oh, okay, so because this cell sees a 3, so in block 9, the digit 3 is forced into row 8, and 3 is here, and this 3 points right. I mean, points left. Again, I mixed up the directions, sorry. These 3s point left to force the digit 3 into this cell in block 7. Or how did I miss this 8? Okay, I'm sorry, but this cell could not contain an 8. It must be a 6, making this an 8, and this a 6. This 6 points right, eliminating 6 from this cell, making this a 3, this an 8, this a 6. This 3 points are making this cell a 7, this a 3, this a 4, this a 3. Okay, I'm just following the markings around. I'm just following the markings that I've done, because I know that they're correct. It's been proven by logic. By correct logic, okay? Yeah, it's important to make sure that all your markings you've done are logical and accurate. Otherwise, you're gonna make a mistake somewhere, so, yeah. Alright, what did I want to say? Again, yeah, now this cell C is a 7, must be a 2, making this cell an 8, this cell a 7, and this a 2 to complete this row. This cell is a 4, because of these 4s. Or, for the row, this 5-8 pair eliminates this missing digit, it must be a 4. And then in row 4, the missing digits are 1, 6, and 7. This cell C6, so it's 1, 7, 1, 6, 7, 1, 6, 7. Oh, sorry, 1, 6, 7. Alright, up here we got 2, 3 for column 1, 8, 9 for column 2, and 5, 7 for column 3. And also, here we got a 1, 8 pair remaining in column 8. Okay, this cell now C7, so it must be a 5. This is a 7 points down, making this 1 and 7. This cell now sees 1 and 7, so it must be a 6. This cell now also sees 7, so it's 1 and 7 like this. Okay, this cell cannot contain a 2. The missing digits of row 9 are 4, 8, and 9. But this cell sees 4 and 8, so this must be a 9, and this cell also sees 4, so 4 ends up in this cell, making this cell an 8. 5 and 8, this cell is completed with a 6, Column 4 is missing 1 and 3. Column 6 is missing 5 and 9. Column 7 is missing 4 and 7. And column 9 is missing 2 and 6. Okay, so this LC is 4, so this is a 7, 4, and I'm just following the markings around, and the Sudoku puzzle is complete. Alright, I finished today's New York Times hard Sudoku in a bit under 21 minutes, so I would say this Sudoku puzzle is fairly straightforward. Yeah, apart from all pairs and triples, like the 1-7 pair in block 8, 5-8 pair in block 5, 3-7 pair in block 6, pairs and triples like those, of course, are a must-know skill in hard difficulty Sudokus. But apart from those, the other key spots include, I would say, the mini X-Wing of 9. The placement of 9 in blocks 7 and 9 formed a mini X-Wing, so that limited the placement of 9 in block 8. Or you could have just looked at row 9 and saw the placement of 9 in row 9, which also affected block 8. And there was the single 3 in block 3, this 3 where I'm pointing at, the intersection of row 3 and column 8, this single 3 was also quite important, as it also, well, oh, I didn't even notice. I just noticed now that I could have placed the 4 into this cell in row 3 right off the beginning. It was because I didn't look at the digit 4 at the beginning. I missed a few spots for it, so yeah. Yeah, I could have gotten those easily, but I just missed them. So yeah, hopefully this video helped. Even if you have any other questions or difficulty that you want to ask, feel free to leave them in the comments down below. I'll be glad to reply you, and I'll try my best to do so. So yeah. Today is September 27th, 2024, in this video I've solved Wordle number 1196 and New York Times hard Sudoku for September 27th. So yeah, I'll see you all in tomorrow's video. Bye!